Ever wonder why a feather floats leisurely in the air, but a stone plummets to the ground? It's not just a matter of weight, but a fundamental principle of physics known as Newton's second law of motion. In the simplest of terms, this law states that the force exerted on an object is equal to the mass of the object multiplied by the acceleration it experiences. Still sounds a bit complex? Picture it this way. If you give a gentle push to a stalled car, it wouldn't budge much, right? But that same push could easily send a basketball rolling. That's because the car, with its greater mass, needs more force to change its speed or direction than the basketball does. So, what does Newton's second law tell us? It introduces us to three key elements: force, mass, and acceleration. Firstly, force. Think of it as a push or pull applied to an object. It's the driver behind any change in an object's state of motion. Secondly, mass. It's the amount of matter in an object, or in simpler terms, it's how much stuff makes up an object. The greater the mass, the more force you need to change its motion. Finally, acceleration. It's how quickly an object changes its speed or direction. The more force you apply, the greater the acceleration, but only if the mass of the object stays the same. So, if you put all this together, you'll find that Newton's second law is telling us something incredibly profound about the way the universe works. It's saying that the force you apply to an object, whether it's a feather, a stone, a car, or a basketball, and the mass of that object determine how fast and in what direction it will move. In other words, it's not just about the strength of the push or pull, but also about what you're pushing or pulling. And it's this delicate interplay of force, mass, and acceleration that orchestrates the dance of planets in the cosmos, the flight of a bird, and the journey of a car down the road. So the next time you see a feather floating in the wind or a stone falling to the ground, remember Newton's second law. It's not just a law of physics, it's a fundamental principle that shapes our understanding of the world around us.